Hi, I'm J-Love. For the past couple of months, I've been working on this really cool project. Before I show it off, let's rewind. Throughout high school, I was on my school's ski team. Every Saturday, we'd go up to the mountains and practice. We'd run the race course over and over, but we never really knew if we were getting any better, as we had no way of tracking our time. Unfortunately, commercial ski timers cost, at minimum, about $1,500, and to get a good one, you're looking at upwards of $3,000. So, come the season of my senior year, a friend and I started designing one of our own. This video will be part of an ongoing series on my channel, documenting my progress on this project. If you would like to see how this project evolves, please consider subscribing and giving this video a thumbs up, as it helps with the algorithm and will help you see more of my content. First, let me demonstrate how the timer works. When a racer is ready to start, they type in their 3-digit number. Then, they line up at the starting gate. When they push off, they push a stick out of the way, which presses this button. Up to 2 other racers might be on the course at a time, so I'm starting off 2 more. Then, when they reach the end of the race, the racers cross the finish line, ending their time. This timer is broken up into 2 modules, one that sits at the top of the race course, and the other that sits at the bottom. The modules are connected via Wi-Fi and work together to determine the racer's time. The top module is powered by a Raspberry Pi 3, and the bottom module is powered by a Pi 0. The top module gets the more powerful Pi because it does most of the calculations and hosts a web interface. My friend designed this circuit based off of an online post that documents how to use a photoresistor with a Raspberry Pi to detect light levels. Essentially, it continually charges and discharges a capacitor. And since there is a photoresistor between the capacitor and the power source, the photoresistor varies the amount of time it takes to charge and discharge the capacitor. Based on that time, I'm able to calculate whether the laser beam has been broken or not. This module is housed in a case I 3D printed. I do not have much experience with 3D modeling, so I was not able to make it super fancy, but I'm pretty proud of what I was able to do. In the future, as I get better at 3D modeling, I'm going to design a lid for this housing, as well as housing for the bottom portion of the timer. The lid is going to be much more complex as it holds the display and buttons. For the display, I chose to use e-ink technology rather than liquid crystal, because it needs to be visible in direct sunlight. If I were to use an LCD display, it would be nearly impossible to see in the mountains, where the sun is very intense. As an added bonus, e-ink displays are incredibly power efficient. Anyways, I think that's all I have to show. If you would like to keep following my progress, please like and subscribe. Thanks for watching, and I'll see you next video.